Okay, hello everyone. Today we are going to look at a new concept. It's called factorial. A factorial? Do you know what is a factorial? So, uh, for example, 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And so on and so forth. That's correct. But let's look at when do we need to use it and where it can be useful. So sometimes you will see problems like this. Look at the first problem here. How many different numbers can you form using 1, 2, and 3 if you can repeat numbers? So how about we write this down and see how many numbers we form? So, three. So I think the first number, because I can repeat them, I can think there is going to be 1, 1, 1. 2, 2, 2. Correct? Now we'll start everything that starts with 1 first. Then 1, 1, 1, 2, 2, 1, 1, 3. 1, 1, 3. And we goes to 1, 2, 1, 1, 2, 3, 2, 1, 2, 3. Take a lot of time. But yeah, but like for this example, let's complete it so we understand the whole concept. So now that like have we exhausted all the numbers starting from 1? Yep. No. No. So which is the next number? 1, 1, 3. 1, yeah. 1, 3, 2, and 1, 3, 3. Correct. That's a lot of numbers. Yes. So how many numbers we count so far? 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the numbers that starts from 1 are nines. 9. Since all the numbers that start from 1, there are 9 numbers that start with 1. There must be 9 numbers that start with 2 and 9 numbers that start with 3. That's correct. So we have how many numbers? We have uh, 27 numbers. 27 numbers, right? So here, let's see what were the keywords that you can repeat the numbers. So repeating is something that's why we could have 111 or 112. And so this was easy because we had only 3 numbers. We were able to count them and add them, and they end up in 27. What if you had 5 numbers? Yes. So when you can repeat the numbers, there is an easy way to think about this is you can see how many numbers are there. So how many numbers are there? 3. Yeah. And we are looking at 3 possible combinations. So here you can actually multiply 3 into 3 into 3 3 times, and then you get that numbers. 3 into 3 into 3 is 27. 27. So when you don't have to repeat the numbers, you can multiply them to themselves as many number of times. No, when you can repeat number. So if this has have been 4, then you could do 4 raised to 4 or 4 into 4 into 4 into 4, and that would have given you the answer. Yes, or 16 square. What 16 square? Square. Don't remember? That's it. All right. So this is not factorial. This is where like we are still focusing on when you can repeat the numbers, you can find easily how many possible ways to do it by just multiplying the number by as many times as the value of the number. So now let's go to the second one. Now we add a little bit of twist. How many different numbers can you form using 1, 2, and 3? But you cannot repeat numbers. Yes, if you cannot repeat numbers, many of the numbers that we use here will not be possible here, right? So if we start with 1, 1 cannot repeat. So it have to go to 2 and 3. So let's see all the possible numbers that we can start and with. We start with 1 is 1. There are only two possible numbers. What about starting with 2? Same thing. 30, 230, 231. And again, starting with 3, there are only 6 possible numbers. So if we So this one, like because the number was small, we were able to do this by Brent easily. But when you see these numbers that like you cannot repeat and you have to arrange certain numbers, then the concept of factorial kicks in. So instead of doing all this, there is an easy formula like how we learn the formula in the previous place, where like we have to multiply the total number in total number of times. Here, what we have to do is do we do it something like call it, because there are three numbers. We do 3 factorial. And how does 3 factorial work? 3 times 2. 3 into 2 into 1. So whatever the number, we start multiplying by a smaller number until we reach 1. So 3 factorial is 3 into 2 into 1. 5 factorial is 5 into 4 into 2 into 1. So, so it's like n minus 1 and then n minus 2 and then n minus. Correct. So n times n minus 1 times n minus 2 times n minus 3 so on until n equal to n minus n. I mean, not n minus n, n minus 1. Yes, until we reach 1. Okay, that's good. So let's look at next three problems and see if you can figure out, is it a case of like a first one where we keep multiplying number itself, or is a case of second where we have to uh, reduce number each time that we are multiplying. So how many ways four students can stand in a queue? Is it a problem of, is it a problem like first one, or is it a problem like second? What about if a bicycle lock has five numbers? How many possible combinations are there for the lock? The first, what do you think the first one is? This one, fourth one. So, if four students can stand, I think it's more like more like the second one, because you can't somehow like clone a student or something. So once a student stands at one place, that student cannot again stand in another place. So this is a problem very similar to this one. Like cannot repeat. Because you can't just clone the students. Right. You don't have a cloning machine. So that's why we have to do here is the answer is 4 factorial. What is 4 factorial? 4 factorial is equal to 4 into 3 into 2. Which is 24. 24. Right. What about the bicycle problem? If a bicycle number, so uh, if it has five numbers, how many? Here you can repeat numbers because if how many possible combinations are there for the lock? It's like you can have a password which is 555. You can have five. Yes, that's correct. So this is similar to the first problem. So it is what we have to do is 5 multiply itself 5 number of time, or 5 is to 5. And let's go to the last one. How many words, doesn't have to be different words, can you make? ABCD. Using ABCD, if you have to use each letter only once. Yes. The keywords are only once, because that it means. Okay, let me just see. How many 4-letter words? How many oh yeah, 4 letter. uh, Only once. So and immediately you can see only once means the question number 2, so you can easily. Yes. It only means what they are asking is that you cannot repeat the numbers. If you cannot repeat the numbers, then immediately what should come to your mind? It's the problem of factorial. Mm. Right? So to see this in way that usually we write in mathematical form is, if the problem is like first one, then we say this is n raised to n kind of a problem. So this is, we have to multiply n number of times, and if it is a factorial, then it is n factorial problem. So n raised to n is more than n factorial because n factorial, the value of n keeps on going down. All right. So that concludes our factorial problems. Maybe in next few videos we can solve few more. But for now, that's it. Have a good day. Bye. Bye.